Before we start looking at any new information with function notation, let's take a second to review a little bit of the function notation concepts we've talked about already. If we look at our three functions that we have, f, g, and h, we're just going to be either plugging values in or setting it equal to values and see what we get. So on the first one, I'm using function f, and I'm going to be putting the -4 in for the x. So I take function f, plug it in, I get 2 times that -4, that's my new input value, and then -1, so that gives me -8 minus 1, which is -9. I'm just putting an input of x, and I'm really getting an output of some sort of y value coming out of that function. G of 10, much along the same lines, is the square root of, replace the x with 10, and then -2, which we know is the square root of 8, which we've seen a lot of times, reduces down to 2 root 2. H of -5, same idea. We're going to have 3 times something squared plus 4 times something minus 6, and we're just replacing all of those somethings with -5s. I do a little bit of calculation, and my calculator tells me that that is -41. Those three are pretty straightforward. You're just plugging the number in and seeing what I get out. Number 4 gets a little bit trickier. I'm taking f of x plus h. Now, one thing to notice is this h right here is not the function h. That's not h of x. That's not that guy. That is just the letter h. You might wonder why we're using h. Well, because in the future we're going to use this a lot. So for right now, I just want to introduce what this looks like. So if I have f of x plus h, let me change the color there. Let's make him a little more red. There we go. This is going to equal, well, f is 2 times something minus 1. And all I'm doing is replacing the x with x plus h. And at this point, I just distribute. I get 2x plus 2h minus 1. And that's my final answer. There's nothing more I can do to simplify that expression. Number 5, the key here is realizing that I have a y value, an output value. So I'm going to grab that 5 and set it equal to g of x, which is the square root of x minus 2. In order to solve, I square both sides. So 25 is x minus 2, and add 2 over. 27 equals x. Lastly, g of 0. That's the square root of 0 minus 2, which is going to end up being imaginary. So I'm going to say that 0 is not in the domain of g of x. If you remember, with domain, the domain of g of x is actually going to be x is greater than or equal to 2. Just a fun little FYI. But the key is 0 is not in the domain of g of x. So that's just all review of basic function notation. What we're going to introduce here is the idea of function arithmetic. In other words, how do I add, subtract, multiply, and divide functions? And I do that just like regular numbers, using the same operations. The only difference is that the answer is going to be a function. So the answers are going to be functions. I get functions when I add functions. Makes sense. So here I have f of x and g of x. I'm going to go through a couple different function arithmetic things with these. First one is what we call f plus g of x. Another way of writing this is f of x plus g of x. They're the same thing. What I do is replace f of x with 4x squared plus 2x minus 1. And I'm going to replace g of x with 8x minus 1. So in this case, I'm just adding two polynomials together. Parentheses don't really mean much. That's just for keeping things looking nice early on. When I add them together, if I grab a slightly different color, I get 4x squared plus 10x minus 2. That is f of x plus g of x. The answer is a function. Same thing for part B. Replace f of x with 4x squared plus 2x minus 1. And I'm going to subtract g of x this time, which is 8x minus 1. So I need to do just a little bit of distribution. 12x squared plus 6x minus 3 minus 8x plus 1. And then just combine like terms. 12x squared minus 2x and minus 2. That would be 3 times f of x minus g of x. Notice how I just take the 3 times all of this right here being f of x. Part C. When I see g of x squared, remember what squared means? It means cross out the square, rewrite what's there. I have g of x times g of x, which would be 8x minus 1 times 8x minus 1. We can go ahead and just FOIL that out and combine like terms as I go and get 64x squared minus 16x plus 1. Lastly, part D. Scroll back down. Part D here. I can break this up and think of it as f of x divided by g of x. It's the same thing, f divided by g and f of x divided by g of x. Go ahead and just replace the functions. So f of x was 4x squared plus 2x minus 1. And g of x was 8x minus 1. Now I could see if the top factors and then try to reduce with the bottom. It's not going to reduce, so I'm not going to go through that process. I am, though, going to consider the domain. It asks for the domain here. And in this case, I'm going to say my domain is x does not equal positive 1/8. So I'm going to give the restriction as my answer, but it's the same idea. So I have my fraction as my answer and my domain restriction. So I can treat these functions just like I treat numbers, add, subtract, multiply, and divide them. The only difference is I get a function as my answer.